The poll everywhere that I'm going to ask you, it's similar to what we've done previously. It's choose the correct coordinate system and then answer these questions about the domain, how many boundary conditions, all of that. Now I need to put this in full screen. Let's close this. So let's switch gears, and I'm going to clear the responses. So give me a second to figure that. Clear all responses. All right, so we're going to move on to this next example. So this is this exact same thing, except I now move the air fresheners to be on one of the walls. So the source term, which has species A, is at one end of a 2D channel, and the sink is on the other adjacent wall. So one example is wall and Febreze. Another example is, let's see, a subsurface tank leaking over a reservoir. Yeah, so I guess you could have a leaky oil tank over here that is kind of diffusing down and over this way. Looks like answers are coming in, so I'll move along. So this looks similar to the first one, except now we have both the X and Y components for most of us. A lot of us definitely think X exists, and that makes sense because the concentration is starting at X equals 0 and it's kind of moving to the right. It's kind of useful to think about what the direction of flux is over here. So you know you're going from high concentration to low concentration that way, because that's where your air fresheners are. But you also have a sink over here that has 0 concentration. So you also know that you're going from high concentration down to low concentration in that direction. So your net motion of flux is like this. So this would be NA in the X direction. This is NA in the Y direction. And this is your net direction of your flux. So what I'm going to say is that means your flux has an X component and a Y component to it. So that means there are gradients in each direction, which means both of these are correct. You need the X and Y components from 0 to L. Anyone have any questions so far? All right, we'll keep moving. How many boundary conditions do you need? Either 2 or 4, I agree. And I'm going to agree with the dominant answer that you need 4 boundary conditions because you have 2 spatial dimensions. Won't harp on that more. Whoops, to do that. Boundary conditions. So the 2 boundary conditions are actually identical to what we had last time. We just moved them around. So constant concentration, constant concentration. Oh, I didn't tell you which ones are which. Seems like you can figure out how to switch things around. I'm going to start with X, then go to Y for boundary condition 1, then condition 2, and I'm going to start with X equals 0, and then go to X equals L when I talk about conditions 1 and conditions 2. So in that perspective, starting with X at X equals 0, that's this boundary condition over here. So that's a constant flux boundary condition. Condition 2, I'm going to say this is X at the other boundary. So that's going to be over here. And I know I only allow for 2 conditions, but that's okay. So let's see if you can re-answer this knowing that this is at X is equal to L. So I see things are moving a little bit. I see the first bar coming down and the second bar coming up with one answer on fixed flux. So again, the fixed flux means that the rate at which molecules pass through the surface is constant. What I'm going to agree with is the one that's emerging over here to say that there's no flux across the right surface. So that's different than saying there's no concentration. You could have a high concentration over here, far away from the Febreze puddle, but the derivative of concentration, the rate at which molecules are moving through, is 0. And that makes sense because this is an impermeable wall. You cannot have flux going through this wall. So that's the same thing as saying the gradient is 0 or the flux is 0 going through that wall. Okay. Initial condition, this is going to be the exact same as what we talked about last time. This can achieve steady state, so you can run this without an initial condition. So X and Y, diffusion in X and Y, I agree. I'm going to still say that there's no bulk motion being induced still because we're still dilute.